So on this lesson, what you're given is a foldable. So if you guys want it to be a foldable, you're just going to make some little cuts. So cut it like to the first vertical line, and then you can have a foldable. And then if you're looking to see a function is set from 1 to 1 with ordered pairs, you flip that out. It tells you yes or no. For a mapping, you can flip that out. If you do not want it to be a foldable, then just fill in it. It can just be a note. All right. So let's look at the inside of the foldable, and you can cut it later. You don't have to cut it now. So a function is when we're talking about a set, a function from set A to set B pairs each element in set A with exactly one element in set B. Now, you guys, I don't think are super used to sets. So a set can just be a group of numbers, letters. It could actually be really anything. So when we're looking at sets, deciding if they're a function from A to B, then the x value must come from set A, and the y value must come from set B. So this first one is a function because all of your x values come from set A, and that is important also that they're all used. So the whole set A has to be used. And then all of the y values are coming from set B. And every value from set A is paired with exactly one from set B. So the x values are never repeated. We got a whole lot going on. Let me erase this. All right, so the x values are never repeated. The y values is fine if they repeat. It's still a function, but the x values aren't going to repeat. Okay, so over here to the right are some examples where you have these sets and they're not functions. So it's not a function when an x is paired with two y's. So that's what happens on this example. So 2 is paired with -3, and then 2 is paired with -1. That won't happen with a function. Each x is paired with exactly one y. All right. It could also happen that the x's and y's come from the wrong set. So our set on this one, the x's have to come from A, so 2, 3, 4, and 5. On this example, the x's are actually coming from set B, and the y's are coming from set A. So it's not a function from A to B. All right, and then the last case with these sets, when it wouldn't be a function, could be when an x isn't paired with anything. So your whole set A has to be used, 2, 3, 4, and 5. On this relation, 3 isn't used, so it's not a function from A to B. So that might be kind of new to you guys. I think the rest of it is going to seem familiar. All right, so this next example is a mapping. So for a mapping to be a function, each value in the domain, which is x, is paired with exactly one value in the range, which is y. So in a mapping, exactly one arrow will come out of each x. So this is a function. This mapping is not a function. So in this case, we have 2 arrows coming out of -1. So this is not a mapping of a function. Another thing that could happen is you could have the domain listed and no arrow is coming out of one of your x's. That would also make it not a function. Okay, so let's look at the table. On the table, each input value is paired with exactly 1. So you can kind of see there it's a pattern. exactly one output value. So again, the input is not repeating. The input is listed exactly one time. If you're looking at a table, for it to not be a function, you would see that that this 2 is repeated. 2 is paired with 0 and 2 is paired with -1. That cannot happen for a function. Okay, another thing that might be kind of new to you guys is looking at it in algebraic form and deciding if it's a function. So when dealing with an algebraic representation, you're going to need to solve it for y. And then make sure that there is only one y for each x. So the case when you would have to do plus or minus, that's when it's not going to be a function. So this example, we start off with it in this form. And then to solve for y, we'll just add that x squared over. So it doesn't matter what x we plug in. We're only going to get one y. So if I plug in 2, 2 squared is 4 plus 1 is 5. If I plug in 0, 0 squared is 0 plus 1 is 1. If I plug in -1, -1 squared is 1 plus 1 is 2. So every x we put in, we get exactly one y. It is a function. All right, this one is not going to be a function. So when I solve for y this time, I subtract the x squared, and then I have to get rid of the square on the y. I have to take the square root, and anytime you solve by taking the square root, you do the positive and negative square roots. So now, if I put in 0, I get the positive and negative square root of 1. So that's 2 answers, 1 and -1. So I put in 1x, I got 2 y's. It is not a function. Okay. And then looking at a graph, almost everybody remembers this. So I think you probably talked about in Algebra 1 and Algebra 2. But a graph is a function if it passes the vertical line test. So the vertical line test tells you that no vertical line will intersect more than one point if it's a function. So let me just draw a vertical line. So let's see if I can do it. I can't. Okay, so if I took this vertical line out, right, it's not gonna let me. So you take the vertical line, you move it all the way through the graph. If it ever crosses at more than one place, then it is not a function. So this one is fine. It's a parabola. Parabola passes the vertical line test. All right. So if you're looking at a graph, it's not going to be a function. The vertical line would intersect the graph at more than one point. So if I took a vertical line and drew it there, it crosses at 2 points. So a circle is a relationship, but it is not a functional relationship. It's not a function because it fails the vertical line test. Okay, so let me give you guys your assignment. This is, sorry, I don't know the page. Okay, so it is on page 44. I want you guys to do 6 through 20 even. It shouldn't take too long. And then enjoy the rest of your weekend.